Now, traditionally, SDLC stands for Software Development Lifecycle, is an application development process for planning and creating, testing, and deploying any information system. Now, typically, the textbook diagram for SDLC is you have a requirement phase where the software development organizations try and get in touch with the clients and obtain as many requirements as possible from the client. Based on the requirements collected, it goes through a phase where the software development team designs um, how to develop the software, so on and so forth. Once the design and architecture are done, people get into coding or development phase. Typically, in the design itself, the project is basically modularized, and then each of the module gets independently or developed. And then once the product is ready, then it goes through a different phase called testing phase, whether the client requirements are met, or how the software is functioning, whether aspects of the design are taken into consideration. All these things are part of the testing. Once the testing is done, the product is ready, so it is ready to be deployed within the client location, so that if the client has a requirement for software development, when the software is ready, it gets deployed, and the assumption is the client gets what they want and their requirements are fulfilled, and they can use this product in the respective organizations. That is a typical software development process. In this process, where you always have one phase ahead of the other, and you get into next phase where when the previous phase is complete. Over a period of time, this particular model has proved to be completely impractical. Okay, because primary reasons being it is kind of like a waterfall model where you move from one phase to the other phase. And then if you want an elaborate view of SDLC, some organizations, like I said, may not have a standardized framework. People can go from initiation, concept development, planning, requirement elicitation, requirement analysis, then design, then develop, then you integrate all the developed modules and test. Once development is done, the implementation starts, where the product is deployed in the client location, and then operationally there will be maintenance, and then post-sale services, and so on and so forth. Ultimately, when the project is done, realizing or project runs out of its lifetime, then disposition is the end of a typical software that is developed. So, as you realize in this elaborate SDLC, you don't see security anywhere. Okay, this is also part of our discussion in the previous and the class before. Because there is no security in the development of software, you get so many software vulnerabilities or bugs because of the unsafe development practices. Here I'm saying unsafe because you don't have any component for security itself. Okay, even in SAST tools, yesterday we discussed how the SAST tools are compiler agnostic and environment agnostic. And most employees are not trained on the secure software development guidelines that we discussed yesterday. So this becomes the important element of today's discussion. Now, there is a methodology that is used within the testing also, which is called shift testing to left. What it means is in each phase that we discussed, instead of waiting till entire product to be completed for testing phase, they wanted to do testing at every phase. Like if you are in coding, then you basically do testing while you are coding. If you want to test your design, you basically shift testing to left, so that you will find whether or not the code that is being developed suits the design. So this is a very popular model. So in this slide, I am going to propose what if there is a shift security to left model. Okay, as you can see in the testing framework, different levels of testings are there, and each of the testings are shifted left way ahead of the timeline which is generally assigned for testing. So what if there is a secure development life cycle? In the requirements itself, you take what are the security requirements that are specific to this project. So as I was mentioning, what if the security is incorporated within every phase of the software development life cycle, where in the requirement phase itself, like you kind of like elicitate security requirements. You kind of like conduct risk assessment. In the design phase, you actually design for security requirements. In design phase, you do some amount of threat modeling. In the development phase, you perform as and when the code is building, like we discussed yesterday. If they follow best practices for coding in the coding phase itself, you kind of like have incorporated security in the coding phase. Similarly, in the testing phase, if vulnerability assessment and fuzzing can be done, you kind of like incorporated security into testing. Similarly, in the deployment itself, if we kind of like configure for security, if we do pen testing and so on and so forth, it is much better rather than waiting for security or testing till the end of software development lifecycle. This image is an example of how Microsoft has incorporated security into each of their software development life cycles. As a result, they claim that Microsoft has overcome at least 90 to 98% of the vulnerabilities on their operating system. As you see, more and more the Windows operating systems we see today are much more stable than what they used to be. By incorporating security within their development life cycle, they are able to achieve great results. And this image is an example of what they have done. In SDLC, they kind of like do the core training to all the developers. Within the requirements itself, they kind of like have templates for reporting bugs. They also have risk assessment within the requirement phase so that they can incorporate security at the requirements phase. For that, they kind of like have templates, and then they also have a process basically for the requirement phase itself. In the design phase, they have incorporated threat modeling, and they kind of like tried and incorporated attack surface within the design itself so that the security is part of the design phase. In the implementation, they are using so many code analysis tools for all kinds of programming languages, not only for 32-bit, but also 64-bit and so on. So implementation phase, also they kind of like incorporated multiple security tools, and then they stopped using deprecated dependencies and header files and incorporated static analysis. In the testing phase, they kind of like incorporated model-based testing, and dynamic fuzz testing basically is to look for the edge cases, and but also incorporate security within the test cases, within the testing process. So they incorporated relevant tools in the deployment phase. Similarly, for release, they also have feedback and response plan and security reviews, and then release archives, so that the security is part of the release. And then at any point in time, if there is a bug reported within the client location, they kind of like because they already have a mechanism to monitor the bugs, they can address these things even after deployment phase. So here is an example of one particular company tried to implement security within their SDLC. But majority of the scenarios that we see today, security is always an endpoint where once the project development is done, it is given to security team so that they deploy all kinds of pen testing tools and SAST tools on the developed product, which may not be an ideal situation. So this slide tries to bring to your attention, just like how industry was able to shift testing to left, I am proposing that what if the security can be shifted to left, so that at every phase there is some element of security to create better software. Over a period of time, industry has given a lot of interest in the traditional SDLC model. As you can see, there will be different kind of people for interacting with the clients. Completely different set of people to design and architect, and whole lot of developers to build the software. Once the software built is done, then it is sent to the testers, and then from the testers it goes to the deployment team, and then almost always the deployment team and the analyst team or the mid-level management team work together in making sure that the client doesn't have any issues. On the other hand, the process where you test, develop, and you design for the product, traditionally they have been working in silos. So there is a lot of integration and deployment issues in most of the software development that we traditionally see. So industry kind of like suffered for over 10 years or so. And then they moved on to new approaches for software development, because the delay between each of this phase and the water model is very time consuming and very costly. So they came up with a model called, if we just discuss what we looked at in SDLC, as you can see, you have separate development and operations. Okay, development goes through, you have planning, then you code, you build, you test, you release, you deploy, you operate, and you monitor. Okay, so this is a perpetual life cycle. This model is called DevOps, where they basically combine development and operations. Typically in development, just like how we discussed in SDLC, there is a design phase, there is a coding phase, there is a build and a testing phase. And then once the testing is done, it is released to the client. All this part goes into operation, where you the company basically releases the product, and then the product is deployed in the client location, and then the client basically operates the new operating environment, and then there is a monitoring. So this is completely a different team, and this is completely a different team in the traditional SDLC. So the DevOps model that has been brought has become extremely popular nowadays, where they combine both development and operations. As you can see, it looks like an infinity. So this process is perpetual. For every release, there is a different versioning, and then you plan, code, build, test, release, deploy, operate, monitor. As you monitor, you kind of like want to scale up the product or make the product better for the future. So you basically again go into plan, code, build, test, and then release the next version. And then you deploy, operate, monitor. As and when the bugs are reported, again those things get developed and then released, so on and so forth. This has reduced development and deployment time significantly in the industry. So people have adopted DevOps very widely for software development. So as you can clearly see, even in DevOps model, there is no security here. So there has been suggestions that to come up with a variant of this model called DevSecOps. Just like development and operations are combined, there is proposal to come up with DevSecOps, where you are combining development, operations, and security. What DevSecOps basically means is incorporating security at every phase of this development and deployment. As you can see, for planning and design, you need policies and threat model. For coding, you need static analysis. And then you do some amount of code review. Once the product is built, you do a lot of pen testing. In the testing phase also, you go through lot of security testing. In release, you basically do compliance validation for all the security requirements that were basically created. And then once you release and then you deploy, you kind of like configure for logs and audit. Once this is done in the operations, you basically monitor, you do threat intelligence, so that whether there is an active attack on the software or not, you detect and respond and then recover. You tend to monitor, and then again this cycle goes on, so that in the next version you again come up with new policies. And then so this has also been widely accepted by the industry. For organizations where DevOps is now being tested, I believe the next phase would be is to incorporate security in all the phases. And maybe 5 years from now, we'll hear more about DevSecOps than DevOps. Are there any questions?
Yes, sir. I didn't hear about this DevSecOps. This is the first time I heard. Uh, in this, we have each step we have security policy, right, sir? With threat model and pen testing.
Similar to that of what we discussed, shift security to left. There is nothing wrong in shifting security to left. It need not be only part of this phase. So just like secure software development life cycle, you incorporate security in every aspect of the, because it is also a development life cycle. In the DevOps model also, we can incorporate secure development. So that is the idea of this slide. So another popular development life cycle is called Agile model. In the Agile model, they follow something called as Scrum. What Scrum means, it is a lightweight, iterative, incremental framework for building complex work. Need not necessarily be software development. A typical Scrum basically have something called sprints. Sprint meaning a cycle. All the requirements are basically noted down in something called a product backlog. Okay. And then all the development team come together. There will be a product owner, and the development team basically decides what are we going to achieve in this sprint. A sprint can be anything between 1 week or 1 month, meaning in one cycle, what can we develop? So that is called sprint planning. In the sprint planning, they kind of like pick up elements from the product backlog. Every time there is a new requirement from the client kind of like lets product owner know about the new requirement, which will be added to the product backlog. And the development team picks all the requirements from the product backlog. In the sprint meetings, they basically decide sprint backlogs, which is the subsection of the entire backlogs. And then they sprint, meaning they spend a time frame, 1 week or 1 month, depending on what is the sprint duration by the development team. And then they quickly do the iterative incremental model for developing. And within this Scrum model, they have something called a daily Scrum. What it means is that they have stand-up meeting every day. In the stand-up meeting, they discuss what are the sprint backlogs that needs to be developed today or on that day. And then, so during the sprint itself, it goes through multiple iterative development. Once the sprint is done, they basically have something called sprint review. In the sprint review, they discuss about the sprint backlog, like what are done, what are not yet done. Whether the sprint has been successful or not, what were the problems are basically discussed in the sprint retrospect. And then for the next sprint, they borrow requirements from the product backlog. They also incorporate the shortcomings from the previous sprint and they add it into upcoming sprint backlogs. So on and so forth. For developing one project, this development team takes multiple sprints, and in each sprint they just like SDLC, they modularize and then they kind of like achieve the tasks one thing at a time. They pick the stuff that is of highest priority and they incorporate that in sprint. So typically in a Scrum model, there is something called sprint planning. As you understand in SDLC, modularization is a very important part. So the whole idea of a Scrum model is to modularize, prioritize, and build the stuff that has to go first or in the first priority. Okay, and then incorporate those things in the sprint planning. Sprint planning is meaning, for example, if your team comes together and wants to develop a product in the upcoming week, it might take several weeks to develop the entire product, but if you consider 1 week as your sprint duration, in 1 week, what can I achieve is borrowed from the product backlog. And then they perform daily scrum and then develop the elements of the product backlog in the sprint duration. In this example, 1 week. Product backlog is basically the client requirements obtained by the product owner and added into the backlog. In sprint, there are timelines where there is a daily scrum where entire team discusses what are we going to work today. And then the sprint review meeting where what has been achieved in this last 1 week. There is a sprint planning where they basically plan for what are we going to develop in the upcoming week. So there is a planning, there is a daily review, there is a post review, and then sprint retrospect is where what worked, what did not work, whether there are team member issues, so on and so forth. So over a period of time, they do multiple sprints to solve a much larger project. This kind of like brought a lot of productivity into software development. So a Scrum typically has a time-boxed daily meetings, daily Scrum, sprint planning, sprint review, and sprint retrospect. Ultimately, customer will change the scope of what is wanted because the requirements are volatile. So when requirements are volatile, these kinds of Scrum methodology is extremely helpful because instead of waiting till end of the product where the client says, no, this is not what I said, or the client says at that time we thought that is going to be our requirement, but the requirement has changed, which basically will put a lot of stress on the development teams. So the Scrum model basically works along with the client, and then because of this incremental sprint model, any arbitrary or intermediate changes proposed by the client can be part of the product backlog. Okay. So when the requirements are unpredictable, then why there should be a predictive planning? That is the whole idea of the Scrum. So the Scrum recognizes these two components. One is the requirements are volatile, and then you don't require a predictive planning for developing unpredictable requirements. Okay. Elements to remember is the product backlog, which is like the requirement phase. Sprint backlog is where modularizing the given client requirements. Sometimes all client requirements are not known in the day 1, day 2. These requirements are elucidated over a period of time. This model kind of like supports that timeline also, where whichever is the highest priority or whichever is the requirement they got first must be really priority for the client. So you can organize your sprint backlogs in the same fashion, either in the order of development or in the order of priority. And then you conduct sprint, and then within sprint you have daily scrum, so that you are always on track of what is happening within your development team. So as a result, as and when the product sprint backlogs are getting completed, that means product backlog is also being addressed, right? So that is how incremental software development model called Scrum works. Are there any questions?
No, sir, no. As per the Scrum model, uh, the kind time consuming is too high, sir. Why? Because every day team has to gather as a meeting, and every day we team has to discuss what is the requirement, and we then they are going to work. So it may take too much of time.
Actually, no, because the daily Scrum is a time boxed. This is not more than 10-15 minutes.
Okay.
Okay, where there will be stand-up meeting where entire team discusses what are they going to work on for the day, and then they disperse.
Okay.
They meet again for stand-up meeting the next day. When the sprint cycle is over, they do a sprint review. Basically, what was our original backlog? What is the current position now? Why we are not able to achieve a particular module? They do it as part of the sprint review. If something is not done, they add it in the upcoming sprint backlogs. Have missed a team member, the team member might be in leave, so the phases that he is responsible for developing are undone. So in the upcoming phases, those will be addressed. As I mentioned to you earlier, the Scrum need not necessarily be for the software development. It can be for anything, including civil, mechanical, and other kinds of engineering efforts.
Yes,
Now,
sir.
if we are incorporating Scrum in software development, so shift security to left, people have done a lot of study and they kind of like came up with a model where Scrum can also be compliant with the secure Scrum framework, where you incorporate security considerations within the architecture. You incorporate security and its requirements in the product backlog. You, in the daily sprint planning itself, you incorporate security requirements and risk analysis. And in the sprint backlog, you basically kind of like create user stories where what if there is an attacker who tries to target this particular module or this particular algorithm, so on and so forth. And then at every phase in the sprint retrospect, what have we done with respect to the security? In daily Scrum also, you can kind of like go ahead and ask security questions. And then within the security deployment also, you kind of like in the deployment also, you incorporate the security part. Okay, so that way you incorporate security in planning, security in design, security in development, security in building, integrating and testing, and then build, and then so on and so forth, where you could, if you can come up with a model where you can incorporate Scrum within software development, it is not that difficult for developers to incorporate security in the Scrum. Scrum was not originally built for software development, but this model seems to be faster than the traditional SDLC. So the industry has adopted this model as part of the agile methodologies. So the entire theme for this presentation is how do we incorporate security within the software development, whether it is a Scrum model or a DevOps model or SDLC traditional software development model.